All right, what's up, guys? This is 2012 number 3. You're given a graph, and you're told that g of x is equal to the integration of f, and this is the graph of f. Okay, so you can think about this graph two ways. You can think about it as f, or if you were to derive this side and derive this side, then g prime of x is equal to f of x. Okay, part A, find the values for g of 2 and g of negative 2. Okay, so if I want g of 2 equals the integration from 1 to 2 of f of t. Okay, so that means I'm starting my integral here, and I'm going to here. Okay, so you've got this triangle right here, and the triangle is to the right of where I'm starting and below the x-axis, so it's got to count as negative. So we've got 1/2 times the base times the height, and that's where I included my negative sign, and that gives me negative 1/4. Okay, if you're confused about why that's a 1/2 right there, or negative 1/2, well, that's 1, 0, and that's 3, negative 1. So that right there is exactly halfway in between, and halfway in between 0 and negative 1 is negative 1/2. Okay, g of negative 2. So g of negative 2 again, you start your integral at 1 and you go to negative 2. So we have this half a circle right here. Well, it's to the left and it's below. So you've got like it's negative because it's to the left, and it's negative again because it's below. So you've got that double negative happening. So that's why he's going to count as positive. And then if I drop a perpendicular right here, I'll have this little triangle right here. He's to the left and above, so he counts negative. And so there we go, there's 1/2 pi r squared minus 1/2 times your base length times your height. And you end up getting pi over 2 minus 3 over 2. Part B, for each g prime of negative 3 and g double prime of negative 3, find the value or state that it does not exist. Okay, so this is the graph of g prime right here. All right, so g prime of negative 3 is just that point right there. Okay, and again, that's exactly halfway between the output of a 1 and the output of a 3, so that has to be 2. Okay, and then g double prime of negative 3, well, I think you would agree that g double prime is the slope of g single prime, and so the slope right here is just the slope of that line, which is 1. Part C, find the x-coordinate of each point on the graph of g, where g has a horizontal tangent line, and then determine if it's a min, max, or neither. Okay, so horizontal tangent lines occur when the derivative is equal to 0. So this is the graph of g prime, the derivative of g, and this guy is equal to 0 here and here. So we have a relative max for g at this point because we're changing from positive to negative. And we have neither at 1 because we're going from negative back to negative. All right, and then part D, it says between negative 4 and 3, find all values of x for which the graph of g has a point of inflection, and explain your reasoning. Okay, so inflection points occur when the second derivative changes sign. The slope of the first derivative is the second derivative. So like, where is the slope of this guy changing sign? He's changing sign here, he's changing sign here, and he's changing sign here. Okay, so I've written it that way. Something you've heard me say in class, inflection points are the mins and maxes of the first derivative. That's the first derivative, and those guys are mins and maxes of the first derivative. All right.